Okay, so in that last video, we had talked about the translation rules, how you can move something up, down, left, and right. And in this video, I just want to go over how you can reflect stuff. All right, so this is going to be like how you would flip something across the x-axis or flip it across the y-axis. Okay. So let's go ahead and look at this first question. Describe the transformation of negative f of x plus 3 as it relates to the original function, f of x. Well, this part's pretty straightforward. Because they're adding 3 on the inside, that's going to move it to the left 3. So that's one thing that's happening. It's being translated left 3. And then here they're attaching a negative to the entire function. Right? So that's going to be this scenario right here, negative f of x. So what's happening is it's being translated left 3 and it's being reflected across reflected across the x-axis. Okay. And I'll try to at least illustrate why this one reflects across the x-axis and why that one reflects across the y-axis. So if I just have a random point somewhere in the coordinate plane, like right here, let's say the coordinates of this point is 5, 2. Okay. If I were to reflect this across the x-axis, it would wind up right about here, something like that. Now, the coordinates for this new point, well, the x-coordinate would still be 5, right? It's still 5 to the right, but the y-coordinate has changed sign. All right, we just added a negative to it. Well, over time, as you do lots and lots and see lots and lots of graphs, you'll notice that they use the term f of x and the term y interchangeably. Like you might see equations that say y equals, I don't know, 3x plus 1. And you might see f of x equals 3x plus 1. They use the y and the f of x interchangeably. All they are they're expressions for the dependent variable or the output of a function. Okay. And so what's happening here by attaching a negative to this f of x, we're essentially taking all of the y values and negating them. All right. That's why the x value stays the same and we just change the y value. And geometrically or graphically, it just looks like we reflected it across this x-axis. Now, instead, if we reflected this point across the y-axis, it would wind up about right here. And the coordinates for that point would be negative 5, 2. And so here, the y value stayed the same, but we just negated the x value. Right? And that's what's happening here. By making the original x on f of x, by making it negative, we're just negating this x value. And so it looks like it's just being flipped across the y-axis. That's what's going on with the notation for these two. So if you put a negative on the outside, it flips it across the x. If you put the negative on the inside of the parentheses, it flips it across the y-axis. Because you're making all the x values negative, and that's geometrically what happens, is it flips it across the y-axis. Okay, so let me do like an actual algebraic notation for what it looks like to evaluate negative f of x plus 3. So we know what the f of x plus 3 part will look like. You just replace the x with an x plus 3, like that. All right, you go to the original f function and swap out the x for an x plus 3. And then this negative on the outside, you just negate this entire expression. So you would just put a negative on the outside. And that would be the reflection of this across the x-axis and left 3 units. You could graph it and see, but that's how you would work out algebraically that expression. Let's do one more. What expression would reflect y equals 3x minus 4 across the x-axis and down 2 units? Okay, so I want to spell out how to do this. I put x-axis, but I meant to put the y-axis here. There we go. So I want to reflect it across the y and down 2. I want to do this in function notation first. So f of negative x, that's going to flip it across the y-axis. Right? That's that part. And then I want to go down 2 units with it. So I'm going to subtract 2 from the outside of this function. That's my answer in function notation, but now I want to actually write out what that would be in algebraic form. It's going to be 3 negative x minus 4. Okay, that's this part where I'm just replacing the x with a negative x, and then minus 2. So if you simplify this, it's going to be negative 3x minus 6. I'll put on a little y equals hat for it, and that's going to be my answer. Let me go on to Desmos, and I want to graph these side by side so you can actually see the reflection. Y equals 3x minus 4. This is the original function, and negative 3x minus 6. This is the copy, the reflection. Now, it's kind of hard to tell that is exactly what's going on, that it's being reflected across the y-axis and down 2 units. So let me, here, I'm going to pause the video so I can show you by plotting a point here. Okay, so what I'm going to do to show this reflection, I'm going to plot a point somewhere on this red function, right here, 2, 2. And I just want to show you where this point gets mapped to, where it gets put on the blue line. Okay, so we said we were going to reflect it across the y-axis, so that would put it right here, bam, and down 2 units. All right. So this point gets mapped to that spot on the blue line. And that's what's happening for all points on this red one. So for instance, if we were, can we find another one? I don't see another spot that is nice. Okay, this one right here. Yeah, this 4, 8. All right, we would reflect it across the y-axis, which would put it right here, and then down 2 units, which would put it right there. Okay, but one of the more, I say interesting, but kind of the special case one is where this point would get reflected and translated. Okay, so this one is on the y-axis, and so when we go to reflect it across the y-axis, it actually stays put. Right? It doesn't. It has a distance of 0 from the y-axis, so it doesn't really change. I mean, you could negate the x value, but it stays 0. So we would flip it across the y-axis and then down 2 units, which is going to put it right here. Anyway, that's what's going on with this one. All of these points that are on this red line, they've been flipped and then translated 2 units down.